I'll get started. In the interests of averting disaster, I am not giving you the test today, right? And I'm hoping that those 2 more days of studying will help. I will. I said I would. I said today that I would take questions if you got questions at the start of class for the first 30 minutes, which now means 25 minutes. And
wait, can we do it like that? How does that make no sense? Oh wait, never mind.
So if you guys have a question about, tell you what, let me give you back your quiz. Where'd I? Oh, where'd I put it? It's up here. Idiot. Jason?
Oh, I thought he was handing me that whole thing.
Hayden?
X's are green, made them all.
Anderson. Chris? Plain sight, huh? There we go. Caleb? John Moore? Let's see here, John. There you
That's right.
go. I love this. This is very, that is very cool. Like the way you write your name. It's just, I love it.
You could say yours was a
Trinity? Do right. Ash, there you go. So you might not have questions about that exactly because we did go over it at the end of last class, right? And for those of you who had to leave early, of course, you've watched the video. Of course, you've watched the video. Well, I hope you've watched the video. So again, what we're doing here is I'm giving you about 25 minutes to ask questions about material that's on the test. And then past that point, I'm going to tell you about how to solve 2 equations and 2 unknowns, which is not tested Thursday. That is material for test 2. But, the show must go on. Otherwise, we won't get through the material we're supposed to. But I think it's in your best interest for me to lecture on material past the test, as opposed to just giving you the test today. Which I really do think if you can look at what you got wrong and try to fix that, it would be, let me just take a stab in the dark and say everybody needs to see this. 2x How do we solve such a problem? Yeah, sure. I'll take that under advisement. So I think we should add 3 to both sides, right? And what I'm saying is we've combined all the absolute value terms together. There's one absolute value. And how do we solve an absolute value equation? Okay, yeah, so 2x plus 3 equals to plus or minus 13, right? So 2x is equal to plus or minus 13 minus 3. So let's see, I'll just write that out. That's either what? Oh, sorry. 10 or what? Negative what? Not negative 10, be careful. Minus 13 minus 3 is what? Negative 16, yeah. So we get x is equal to 10 over 2 or minus 16 over 2. In other words, yeah, 5 or minus 8. Now, when you guys took the quiz, there was, probably 2 out of 3 students in here have something wrong with this kind of problem. A lot of you got one of the answers but didn't get the other, right? That's understandable. But remember, when we got an absolute value equation, we kind of expect to get 2 answers most of the time. Does that make sense, I hope? Let's look at an absolute value inequality. I think that's another thing we probably could use some work on. So what if I have 3x, well, make it harder. Let's say 3 minus 2x less than 4. And we want to solve this inequality. How do you solve an inequality like that? So one of the things you guys need to watch out for is this is not the same as this. The way you solve these 2 problems is really quite different. All right? So the less than, what we do is this just means minus 4 is less than 3 minus 2x is less than 4. So remember that day I said if we have like absolute value of a is less than c, that means minus c less than a less than c. Whereas if we have absolute value of a greater than c, then we either have to solve a less than minus c or a greater than c. So like I'm thinking of the a as being the 3 minus 2x. I'm trying to make that quantity absolute value less than 4. What that means is that the absolute value has to be between minus 4 and 4. Not that one. So like, I mean, I can explain that on a number line. Let me do it. So you can imagine the number line. On that number line somewhere, there's 3 minus 2x, right? To say that the absolute value of 3 minus 2x is less than 4 is to say that the distance is like within plus or minus 4. So it's got to be, I mean, that is what absolute value of a number is the distance of the number from the origin. Well, anyway, let me not draw that picture. I don't know if it's really helpful. Where'd my eraser go? Where did I put my eraser? Let me go back to your previous advice to me at the end of last class. Don't explain so much. So, all right. So we do this, and then we make our usual steps, right? So like we want to isolate the variable. So I suggest we subtract 3 across the board, right? So minus 4 minus 3 less than minus 2x less than 4 minus 3. Of course, minus 4 minus 3 is minus 7. 4 minus 3 is 1, right? And then what do we do next? At least half of you don't have this down, the next step, because you made a mistake in the other problem or this problem where when we divide by minus 2, what happens? Yeah, the inequality flips, right? Which we could rewrite this as minus 1/2 less than x less than 7/2. And that would be a perfectly legitimate way to write the answer, unless I did that pesky thing of, say, leave your answer in interval notation, the dreaded interval notation. And if I had done that, then the answer would be minus 1/2 to 7/2. Why did I put the minus 1/2 first? Oh, that's just the way we order the real numbers. So like left to right, you know. It's like 7/2 is here, and minus 1/2 here. So we read left to right. So if you go to an Asian country, they do the intervals the opposite way. Is a lie that you shouldn't believe. Sorry. What's that? No. I mean, there's not a good way to. That's really. It's just like. It's a definition. It's not. There's not really a reason for it. It's. We just by assumption we write the smaller number first. You know. So. Somebody had a question? My ear. Oh, is that what you're asking about? It's just because I get into trouble when I think about greater than. So like sometimes I'll take a greater than sentence and convert it to a less than sentence, just so it's like more in line with how we write the interval. Otherwise, I might be tempted to write like 7/2 to minus 1/2, which would be, you know, it's not. I mean, at least 2 or 3 of those steps you could skip in your solution. I wouldn't take off points. But that brings me back to another point. Many of you are just writing down answers with no work. Like I might have let that slide on the quiz. I graded the quiz very very leniently, very leniently, and so like on the test, the partial credit on the quiz is about 50%. Like that's not the partial credit I give on a test. On a test, I'm more like 20-30% for like madcap insane answers. If your answer is only moderately insane, I give like 60% credit. If the answer just has a hint of insanity, I give you like 90%. You know, so like my partial credit it's varied. It depends on how off from correct you are. But in the quiz, I grade very fast, so I either give full credit or half credit. I'm not kind of like, I don't really have a more nuanced grading system for the quiz today. Sometimes I might, but I didn't have enough time today to be more careful. And I think it's in your interest that I was not more careful. Yes. Domain and dimensions. Yes, we can talk about that. Let me do this one. So what is the difference between this and that? So in pre-calculus, on their quiz, because you guys have some of the same problems, in pre-calculus, I gave them this kind of thing on their quiz. And then I gave them that kind of thing on their test. And you know what they did? They assumed it was the thing that I had on the quiz, on the test, but it was not. I just changed this to that, or vice versa. So you need to think as you go through these problems. You have to think about which kind is it. Is it a less than or is it a greater than? Because you solve them really differently. Let me just, if I looked at absolute value of x less than 5, right? If you think about, here's 0, right? Here's x. This says that the distance from 0 to x is less than 5. So if you go here to 5, over here to minus 5, anything in there solves that inequality, right? So you have minus 5 less than x less than 5. In contrast, if you have absolute value of x greater than 5, that means that from 0, you're not in here. That means you're further than 5 away. So that means your x is like over here, or your x is like over there. In other words, x is less than minus 5, or x is greater than 5. And that's why they have to be done differently. You already got it? You already got it? He's already... All right, so in other words, I can't write this kind of compound inequality for this case. I have to break it into 2 distinct inequalities. The one is 3 minus 2x less than minus 4, or 3 minus 2x greater than 4. Either one of those cases is going to give me a solution to the stated problem. So we subtract 3. And then we divide by minus 2. When we divide by minus 2, we flip the inequality, right? Which gives me x greater than 7 over 2, or x less than minus 1/2. So in interval notation, these are things like in 7/2 to infinity. These guys are the things in minus infinity to minus 1/2. And so the answer is a union of those two in interval notation. That's how I do that problem. What's that what? The U is for union. It just means put these two sets together. So like I could say that this class is a union of the people sitting in that row. Is that a row? This column, that column. These 3 columns union together give me the whole class. You guys asked me to work a problem a second ago. Which one was it? Domain, range, and dimensions. All right. All of the above. How about you guys? You guys make up the test and let me take it next Tuesday. That'd be better. Or Thursday. We're having a test Thursday. This Thursday.
I thought he said this coming.
Stop it. Oh, so sorry. Oops. Yeah, I know. I was going in.
With the bottom.
Yeah, I am sorry. I'm sorry. I will recreate the magic. Ah. Mr. Computer, of course. That's how I always answer my children's question. If they ask me who made whatever, I'll just say Mr. Whatever. Just my standard answer. Also, if they ask me how long it is to anywhere, it doesn't matter where we are, I will say 2 minutes. What's fun is when it's actually 2 minutes, and then they ask their mom, and she's also like 2 minutes, and they're like, what? And the thing is, if we're in a new area, sometimes it actually is 2 minutes, and they just don't know, so it's fun. But anyway, I digress. Which one was it? Domain. Here, f of x, 1 over square root of 3x minus 8.
Can you do the one with problem 9 so I know what to do? Yeah, because I'm so confused on what you just wrote on the board. I need problem 9 on the quiz.
These are just like that.
X equals 2 divided by 5x plus 10.
Yeah, that's just the same song and dance. I mean, all right, I will get rid of the offending square root, as that may be a pre-calculus operation. My apologies. There you go. Is it better? Okay, so what we need that we don't have division by 0, right? So 3x minus 8 equals to 0 is unhappy. Who's buzzing me? So many realtors. Oh, I can't keep track of them all. All right, so 3x equals to 8. So we get in trouble when x is equal to 8/3. So this must be avoid this, right? So the domain is x such that x is not equal to 8/3?
Is that the answer?
What happened? For the, well, if I said write the domain in interval notation, if you put x equals to 8/3, then that, I mean, that's not quite right, right? Because you should say, that will work. That will work. Yes, you could say the domain of f, you could write this sentence, domain of f is x not equal to 8/3. This would be a completely legitimate way to express the idea. When I see students write x equal to 8/3, it hurts me because it's the opposite of the answer. You know, it's like everything but that. So, because the domain is everything except for 8/3. So if you say x equal to 8/3 is the answer, it's like you tell your little brother, don't touch me, and then he's like, okay, and he touches you, and you're like, no. And he's like, well, it's that. You know? Do you have a little brother? No, but it makes sense, right? They're like that. Oh, the other one. So we need x plus 2 not equal to 0, right? So x is not equal to minus 2. So a way we could keep ourselves out of trouble is instead of writing equals, we could write not equals at the start, and then we would make steps and get to the not equals thing that would make us happy and make the teacher not feel like he needed to take off a point because he's worried the student didn't understand the question. And I really don't want your points. I'd like you to keep them. So please write like it does not equal for this kind of problem. Dimensions. You guys want to know about dimensions, right? So dimensions, traditionally length times width. Right? You might buy a kitchen table, right? And it's like 30 inches by 60 inches, right? Something like that. That's what we mean by dimensions. You guys have heard of this before, right? So that's what I meant by dimensions, like the length by the width. So the question asked what? Well, if you actually multiplied the length times width, that would give you the area. But here I'm not actually multiplying, I'm just saying, I know, it's length by width. So, you know, if I said, okay, so example, have fence with width twice the length and a perimeter of 600 feet. Find dimensions. We could draw a picture, right? So I'm going to say this is the width. And actually, I'm saying that's the length. Sorry. And the width is equal to what? Yeah, twice the length, right? So W is equal to 2L. The problem I think that you had on the quiz, it wasn't like twice, it was like plus 40 or something, right? So there's variations on this theme, but, right. So this would be L, that would be 2L. What's the perimeter? So we do what? Like L plus 2L plus L plus 2L again, right? Which is how many L's? So 6L equals to 600 feet. So what's L equal to? How to what? What happened? $100 feet, right? Divide by 6. So then what's the width equal to? So, I mean, a different way I could ask the question would be to say, find the length and the width of the rectangle. I'm sorry if saying ask to find the dimensions was like confusing. That was not my intention. I could also say, find the dimensions. I could also say, also find area. What would the area be? If I give you, yeah. I don't doubt it.
You said dimensions, and I was like, yeah.
Length times width, right? And so what's that? 100 feet times 200 feet. So what's that? 20,000 square feet? I think. Yeah. So I know a lot of you had to go to that exciting seminar thing at the end of the quiz day, right? So you missed me going through these problems, but I did go through each one of the quiz problems one after the other. We wrote them up on the board. I think you can see the video when you look at it, so you can look at that. And the solution's also posted where? Course content, right? In addition, I have posted the quiz I gave to the other section. Have I? I haven't done that yet. And the reason I haven't done that yet is because the other section, I postponed their quiz from Monday to Wednesday because I have similar feelings of impending doom if I gave the test as early as I wanted to in here in the other section. So I pushed their test back too. Their test is pushed back like to Monday, I think. But they have their quiz this upcoming Wednesday. And so once that happens, I will post their quiz along with the answers to their quiz. That'll be posted like, midday Wednesday. So you can look at that to prepare for the test Thursday as well if you want. That's another list of like questions that would be right down the middle for your test. Like if I put a question on the quiz, that means I think it could be a test question. Yeah?
Can we push ours back to Tuesday? Because I just got a tutor, and I feel a lot better if you and me can like.
What's that? Who else would like for me to push the test all the way to next Tuesday?
Because I got two.
You got tutor too? Your wish is my command. All right, so test 1.
What it says, do you allow the one-page note night?
Yes, you're allowed one page of notes, front and back.
Yeah, I say every day this week. We don't do another section. We just study this now.
Let's see here.
Straight.
What's the date for next Tuesday?
I'll look it up for you, I got you. It is the 22nd.
Yeah, that's
all right. So now, the other thing is, I know some of you have had trouble getting my math lab to work. Some of you may be still having trouble getting my math lab to work, but I would remind you that I took several hours to print all of the homeworks and post them in course content so you can look at them. Yeah. And if you have trouble with that, because Blackboard is sometimes annoying.
Paper copies?
Paper copies.
Oh,
No.
dude, you hand out paper, I'll have every homework in, I promise. Every single one.
Yeah, I don't think the math department would be happy if I printed paper copies
I will bring
of that
you
book.
paper, you need my paper.
But
Email it to me.
if Blackboard does not delight you and you'd like to see them all in one drive, I do have them saved in a Google Drive. If you email me and ask me, I will send you the link to that Google Drive.
Because sometimes Blackboard, because no, my psychology teacher won't work, like, their link that you put in there, it will just take you back to the wrong page.
I know it. I've seen it myself. And so if that happens, you just email me. I will send you that Google link. All right? Because they've got like a printing budget and, you know. Not to mention the, not, oh, curses. Are we okay? I'll stop. No, I don't. I have not erased the bottom yet. So, now the printers here are very persnickety. They tend to jam up a lot. Let's see here. So, so we're on to linear equations. Well, not linear, systems of linear equations in two variables. That's the next thing on the schedule. Systems of linear equations in two variables. And so the two variables we usually use in here, at least I will today without exception, is x and y. But really, the things we're learning, you could just as well do in other letters, fine. So I'm going to start with an example. So suppose we wanted to solve x plus 2y equals to 3 and 2x minus 2y equals to 0. How would you solve a system of equations like this? So one way you could solve it is by something called elimination. We can use what's elimination? Elimination means you solve for one of the variables in terms of the other one. All right? So what do you guys think? Let me number these. This is equation 1. This is equation 2. Which one should I use to start with? How about, which one's easier? What's number 1? Oh, okay, yeah, I see it. So you're saying number 1, x plus 2y equals to 3 tells me what? It tells me that x is equal to 3 minus 2y, right? So that gives me x in terms of y. All right, so then we plug into, let me call this star. Actually, let me call it 3. Plug 3 into 1. Plug 3 into 1. And so what's that give me? Oh, that's a bad idea. No, we don't want to use, we already used 1, right? So we should use 2. Use the one you haven't used already. So 2 is 2x, right? Minus 2y. Let's see here. So that's 2 times 3 minus 2y minus 2y. All that's equal to 0. So part of the reason I don't feel too bad about covering this material before your test 1 is because we find ourselves reviewing a very, very likely test 1 question. One variable, one unknown, linear. This is a very likely test 1 question, isn't it? Something like this, right here. This thing we got to. How do you solve that? I heard distribute, music to my ears, so I got 6 minus 4y minus 2y equals to 0. Can we clean that up? Yeah, 6 minus 6y equals 0. We can do better, right? That's 6 equals to 6y. So divide both sides by 6, and what do we got? Right. So 1 equals to y. Well, there's no minus. There's no minus.
It was a negative 6y.
But we added 6y to the other side, right? So when we move it to the other side, it changes it to plus 6y. You're fine. Now, okay, that's great. But when we solve a system of equations, let me give this name of system of equations a name. Let me call this whole thing star. So star is equations 1 and 2 collectively, all right? So we're trying to solve, our goal is to solve star all at once. In other words, solve 1 and 2 simultaneously. So that just means at the same time. So sometimes people talk about the simultaneous solutions of a system of equations. All that's just fancy talk for saying we're solving all of them at the same time. All right, so y equals to 1. What else do we got? How about x equals to 3? Yeah, 1, I heard 1 because 3 minus 2 times y, right? Using 3. So x equals to 1, like you told me. So thus, and often people write the solution as a pair. 1 comma 1 is the solution to star. Okay, great. Let's take a second to try to understand geometrically, like, what just happened. What is the graphical meaning of what we did? So let's take 1. That gives us y equals to, I'm going to solve for y. We get 3 minus x over 2, which, if you like, is minus 1/2 x plus 3/2. So I'm just taking equation 1 and solving for y. Equation 2, if I solve for y, what do I get? Equation 2 is the same as 2x equals to 2y, right? So really, equation 2 we could rewrite as y equals x. Equation 2 is just y equals to x. So what I'm saying is take both of the given equations, solve for y, all right? And then we can graph, right? Y equals x, well, that's this guy. Slope 1, y-intercept is 0, right? The other one has a slope of 3/2. Right? And it has a negative slope. Minus, it goes down 1 and over 2. So negative slope like this. So if we think about it, right, if we have two lines, and we have an equation which defines one line, we have an equation which defines the other line, right? So the graph of those lines is the set of all points in the plane where that equation holds true, right? If you look at the point where both of the lines cross, that's where both equations hold true, right? And that's what this algebra we just did means. It's where both of the linear equations hold at the same time. That's the point of intersection graphically. And so what I'm telling you is this algebra that we just went through to find that this point is 1, 1, that's the meaning. The solution to a system of two equations and two unknowns is the point where the lines intersect. All right? If they do the lines have to intersect? Yeah, this is not on the test, right? I mean, when I push a test back, it's not to put more material on it. That's crazy. No. No. This is on test 2. Dose. Test 2. No. I mean, you focus your worries on the material for test 1. Unfortunately, we only have a limited amount of class time in a semester, so we must go on. But you should pay attention because this will pay off when you do test 2. So, I hope this makes sense. All right, now, so one method of solution is elimination. I just showed you. The other method of solution, we can use. You could say method. You could say technique. We can scale equations. That's just fancy words for multiplying by non-zero number. And then we can add / subtract equations to eliminate variable. So the other method is instead of just, so like elimination, typically what people do is they just pick an equation, solve for a variable, plug it into the other one, right? That's just mechanical. You can just always do that, but when you do it, it can come at the cost of some pretty nasty algebra. You can get fractions and stuff. If you use this rescaling and adding and subtracting equations idea, you can kind of always avoid fractions if we can avoid a lot of the fractions if you're careful. So let me show you an example. This will be example 2, obviously. That was example 1, I think. All right, so if we had something like 2x plus 3y equals to, I don't know, $13. And then we had, like, I don't know, 3x minus y, well, let's say 7y equals to -8, I hope. All right. Now, you could do elimination if you wanted to, right? You could solve one of these for y, plug it into the other one, but I would say I don't want to do it because I'm either going to get a third I'm going to get like fractions with thirds, or I'm going to get fractions with a seventh. So like a better way to solve this kind of problem is to use rescaling. So what we're going to do is we're going to make these two kind of meet in the middle. So I can take this one and multiply by 3. And that will give me 3 times 2x plus 3y equals 3 times 13. And this one, I'm going to multiply by 2. Multiply 2 by 2. And that will give me 2 times 3x minus 7y equals 2 times minus 8. So, of course, that's 39. That's minus 16. And so what we have is we've got 6x plus 9y equals 39. And we've got 6x minus 14y equals minus 16. The reason this is nice is because now if I subtract the equations, the 6x's cancel. And this is something we can do. We can add or subtract equations. So I suggest we subtract the equations. When we do,
Where do you get the 2 and 3 from?
Yeah.
Over there to the left, or
How do you know
mm,
you pull it out?
I did pull it out from the thin blue air. I mean, basically, I'm looking, like, I want to make these match up. So the least common multiple of the numbers is what you want to aim for. So if I kind of multiply the top one by 3 and the bottom one by 2, then they're going to meet at 6. That's the idea. But there are other problems where that is not even needed. Like the next example I work will be easier. We'll just be able to add and subtract equations. But I wanted to start with one that's a little bit more substantial. Okay, so I mean, if you want to see what it looks like when you try to solve one of these with elimination, watch the video from yesterday in the other section, and you'll see how horrible it is. And at the end of it all, it was like, so we don't want to do it this way. And like, there were like 3 people that just like, I just destroyed them. Like, they just went like, oh, it just hurt them so deeply. I'm trying not to do that to you guys, as the crowd reaction last time was so bad. So I'm just trying to stick straight to the easiest way. So the 6x's cancel. And what's 9 minus 14? Oh, excuse me, 9, we got 9y what? Minus a minus 14. 39 minus a minus 16. So I got a 25y, and then that equals to what? What's 39 plus 16? 55. Curses. Well, apparently y is 55 over 25. So it's 11 over 5. Now how do we find x? Yeah. Plug the y in where? Either one of them. Great answer. So we'll use 1, right? So we've got 2x plus 3 times what? 11 over 5 equals to what? 13. So that gives us 2x equals 13 minus 33 over 5. 13 is 65/5. So I've got x equals to 65 minus 33 is 32. So it looks like 32 over 2 times 5. So in other words, x is equal to 16 over 5.
This makes more sense than what's on the test. Or the quiz.
Yep. Well, there's nothing about domain here, right? It's the algebra part of algebra, right? The domain, the inequality, like inequalities are harder. I mean, there's no question about that. Like, I understood equality years and years before I understood inequality. If you can recover by the final and show me that you understand the material with for the whole class, like if you can, on the final make a solid passing grade, and I don't mean like 68, I mean like 75 or higher, it's very, very likely that I would pass you in the class. But that doesn't just happen by accident. Like I offer this always, but the number of students who actually change what's happening to make that a reality is pretty small. So like don't misconstrue it to be like an automatic thing. Like it requires fixing whatever's happening.
I'm just trying to make sure if I fail this test, I still got a chance.
Yes, if you fail this test, you still have a chance. Absolutely. That is true. If you fail the next test, you still have a chance. If you fail all 3 tests, you still have a chance, but you have
I
to.
don't plan to fail this test. I only mean
But,
to fail this next
it's.
The next one, I'm like, I feel like I got hope.
But I much prefer for students to make regular progress towards passing the class as it's going, as opposed to waiting till the very end to show me that
So how we
it
doing
clicked.
the finals?
Yeah.
How we doing put it into this test?
Yeah, I prefer not to grade the class by the final. Like it's. But I'm not. I do pay attention a lot to the final because I think it's important if a student has been struggling but they overcome and they learn the material by the end of the course, then I should respect that, I think. I mean, so. So my grading is more nuanced than some people, but don't misconstrue that it in practice it doesn't happen that much.
Okay, so we do
Anyway.
good on all the tests and we fall on the final.
That's not good. Is it?
Well, what I'd like to do is fail you.
Oh, I
What's
see.
it like to do?
Because that.
But and then I've already given, the syllabus has been written, certain numbers of points have been allocated to earlier tests. You have what you've earned already, so that protects you against my desires. Okay, so we could graph these again, and we could see that that's the point of intersection. All right, these are lines that are skew. They have different slopes.
Okay, where it says x equals 32 over, does that say 2 times 5? Or
Yeah, 2 times 5, because this is 32 divided by 5, but then I divided both sides by 2 to get that. And then like 32 is 16 times 2, so I canceled the 2's and it left me 16 over 5. I'm suspicious of these answers, though. And when you're suspicious of answers, you should do what? You should check them. And we can check answers here. It's like pretty easy to do. So let's test our solution, which was 16 over 5, 11 over 5. So let's try equation 1. Supposedly, 2 times 16 over 5, right, plus 3 times 11 over 5, that's supposed to be equal to 13, is it? 2 times 16 is 32. 3 times 11 is 33. So we've got 32 plus 33, all divided by 5. So that's 65 over 5, which is, by the way, 13. So good, we didn't make a mistake. Which means I made a mistake in making up the problem myself, because I was trying to make the answer 2 and 3. I shouldn't tell you that. This worked exactly as I intended. No arithmetic mistake has been made by me in my internal logic. Let's see here. How about the other? 3 times 16 over 5 minus 7 times 11 over 5. What's that give us? 48 minus 77 over 5, which is what? Are you sure? What's 48 minus 77?
-5.8.
Negative 29. I'll take that minus 29.
Oh, I got -29 on the top.
Yeah, minus 29 over 5. Is that equal to minus 8? It is not. What does that mean? That's right. What does that mean, though?
Gotta go back and read
You
it
gotta
all.
redo the whole thing.
That's what it means. Well, hold on a second. What do you do when, this is a good question, like on the test, you do something like this, and you got 5 minutes till the test is done. Should you erase it like mad?
Just erase
No,
that you
do not do that. What you should do is erase that you checked it. See, yeah, now I know you're going to do that, so I'll be watching for it. But very funny. No, my advice would be draw a single line through it, like collectively, and say there's a mistake in here, and then you go and you try to work that problem on the back side of another page. Don't destroy your work, because you might not have time to complete the problem again. May or may not, right? So like, don't erase it all. Like, just work it again on a different page. Maybe you can escape. Now, the other thing you can do is try to find the mistake. I have limited success with this. Sometimes it works, sometimes it doesn't. There's a mistake in here somewhere. Where do we make it? Let's see here. So to start with, so like, 3 times 2 is 6, 2 times 3 is 6, that's fine. 3 times 3 is 9, 2 times 7 is 14, 3 times 13 is 39, 2 times minus 8 is minus 16, that's good. When I subtract here to here,
Wasn't that 9 and 14 walking from negative 5 1?
well, 9 plus 14 is 23. Oh, there it is right there. Who told me 25? It was, you were 25? So it was not, that was supposed to be 23. That was 23. That's where we, but you see, it is so easy to make a mistake in these problems. It's actually very important to go back and check your answer when you're done with these, all right? And the same is true for your linear equations and also your absolute value equations on test 1. It just takes a minute to take those numbers that you find and plug them back in the equation and see if they work or not, right? Take that minute to do that. You can find out if you made a silly mistake and maybe fix it, right? And not have to rely on my final to fix your grade, Let's see here. So y equals what? 55 over 23. Is that 55? Now I'm starting to doubt that. No, that's 55. 55 over 23. So we're supposed to have put. What's funny, what's amusing is it did solve equation 1. Isn't that funny? But we have to solve both equations at once. It's not enough to solve one equation. We have to solve both. That's what it means to solve simultaneously. So 55 over 23. Oh, ay. Yeah. Well, yeah, I need a calculator. I mean, so we got 2x equals, what's 3 times 55 is 165. 165 over 23. That's a move it to the other side, so that's a minus, plus 13. So